আচ্ছা, এটা এখন রাখবে?
আমাকে যেতে হবে, দাঁড়াও, আমি হাতটা দিয়ে আছি, আমি যাবো একবার দেবাশিসদার সঙ্গে দেখা করে আসবো। মন তো আমার ভেঙে গেল, টাকা দিয়ে ওরকম একটা বড় ভবনে একবার দেখা করে আসবো।
Kindly mute your microphones, please. Kindly mute your microphone, please.
Am I audible?
Yes.
Yes.
Good evening, everyone. I am Dr. Pranita Howley from Department of Physics, Prabhu Jagatbandhu College. On behalf of our college, I am honored to welcome you all to the workshop Data Camp Solving Real World Problems with AI and Python. It's great to see such an enthusiastic group of gathered here with a shared interest in data, technology, and innovation. We are living in a time where data is everywhere, whether it's in healthcare, business, education, or even our daily digital interactions. The real challenge is not just collecting data, but understanding it, extracting the meaningful insights, and using those insights to solve the real world problems. So this is where tools like Python and the power of artificial intelligence come together. As we know, Python has become one of the most accessible and widely used programming languages for data analysis due to its simplicity and versatility. When combined with AI, it allows us to move beyond basic analysis and build intelligent systems that can predict, classify, and even automate decision making processes. In this data camp, we won't just focus on the theory, instead, we will take a hands on approach, working with real data sets, exploring practical challenges, and learning how to apply tools like pandas for data handling, matplotlib for visualizations. By the end of this workshop, I hope you will not only gain the technical skills but also develop the confidence to approach real world problems with a data driven mindset. So now it is my great honor and privilege to invite our principal sir, Dr. Subroto Kumar Rai, to share his valuable words with all of us. Sir,
Hello.
yes sir.
Hello, good evening. I'm audible. Am I audible?
Yes,
Yes,
sir.
yes, yes.
Okay. Today, that is 24th April 2026, I think it is a important day in the history of Prabhu Jagatbandhu College because the Department of Physics organized the data camp. Basically, this is to solve the real world problems with the help of artificial intelligence and Python. So this department organized and in collaboration with the Department of Computer Science of PJC, Prabhu Jagatbandhu College, and Teach Python Group. So particularly our college is indebted to teach Python group because they have extended their cooperation to not only to organize the such data camp, the data science program, but also they actually the teach Python group not only the cooperation but also extended their service to the population present here who are interested to update themselves in the data science, which is a high need of the day. And with this, after the training or after the participation in such program, they will be enriched, their knowledge base will be developed, and they will be updated. All the participants, maybe inside the college, outside the college, that doesn't matter. The matter is, it is a milestone that the Department of Physics, in collaboration with the Computer Science Department and also the Teach Python group, they have created a landmark in the history of Prabhu Jagat College, organizing such type of data science camp. It is the recent, very recent program, knowledge, which will enrich all the members, and through these members our greater society, maybe the student population, maybe the students, maybe the others of the society will be benefited in micro area and also in the macro area. It is not only for the data science, is not only for the physics department, it is the interdisciplinary course. I am actually belonging to the economic science. I am also interested to know the ABC of the data science. I shall try my best to participate as far as possible, despite my very business or the busy schedule. I will participate as far as possible, and it is not only serve or upgrade the knowledge base of the physics, chemistry, mathematics, statistics, electronics, and other and computer science and other science departments, but also the social science particularly, they will also be benefited through the participation in such a type of the data camp. And not only the physical science, not only the life sciences, not only the economic science, but also the humanities group, including the commerce department, commerce faculties and the students of the Department of Commerce, they will also be benefited from this course. So I searched the where actually such type of courses in foreign outside India who are actually uh, going to cultivate this type of data science knowledge base. I located an institute in the Germany. They have the master level course, and also a few developed countries. And in our state, it has been started, so far as I know, the Kollan University, the master, the data science course is taught, is being taught. So I think the Prabhu Jagatbandhu College, the Department of Physics, Department of Computer Science, and also the Teach Python group, they will provide or serve the need of the day, or the upgradation, for the upgradation of the knowledge base of the participants. I already told that it has uh, a tremendous impact, a significant impact on the society, and this will be done to the participation in this course. With these few words, I'm not going to waste the time. I welcome all the faculties, means the resource persons. So far as I know, uh, just a minute, I'm just forgotten the names, but yes, I got it. Uh, Here, just a minute. Yes, yes. Uh, Data structure. The faculties from the different parts of our state, I think Dr. Urunabo Odhikari, who will teach the data structure with Python. Dr. Ovijit Kalgupto will teach the real data and the data visualization with Python. Riti Roy will teach decoding data, applying supervised and unsupervised machine learning algorithms to real world problems. And Dr. Kaushik Basak will teach AI versus superbugs. Dot dot dot. Dr. Amit Kumar Chattopadhyay will also teach here, and Dr. Ruthi Dasgupta will also teach. And of course, whose name, who first discussed with me about this, our HOD physics, Dr. Kisor Mukhopadhyay, who first approached me whether such type of course can be conducted or not, sir. I at first, after listening it, I gave my consent, permission from the end of the college authority. Yes, you can organize this program because it has a significant impact on the educational society and also the greater society. So, with these few words, I welcome all the faculties, of course, the faculties of the Department of Physics of Prabhu Jagatbandhu College, faculties of the Department of Computer Science, and the members of the Teach Python group. I welcome all of them, and also the professors, research scholars, postgraduate students and others participated in this program. I welcome them and wish a grand success of this program so that the college, the Department of Physics will make a victory and also create a landmark in the history of Prabhu Jagat Bandhu College, Andul, Howrah. So again, I am wishing the grand success of this program, that is the data camp, for solving the real world problems with artificial intelligence and Python. So Dr. Kisor Mukhopadhyay, Department of Physics, HOD, Dr. Promita Howley, he is the junior most member, almost the junior member of this department. I'm happy that she initiated the talk about this subject, and also I am mentioning the name of the senior most member of this department, teaching member of this department, Dr. Dolun Chapa Saha, Dr. DC Saha, and also other faculties of the physics department, the computer science department, again the members of the Teach Python group. I welcome all and the grand success of the program. Namaskar.
Thank you, sir. Thank you for your valuable time. Without further delay, we will start our session. So, it is now my pleasure to introduce our today's speaker, an integral part of our team, Dr. Kishor Mukherjee. Dr. Kishor Mukherjee is presently an associate professor in the Department of Physics at Prabhu Jagat Bandhu College in Andul, Howrah. Prior to his current appointment at Prabhu Jagat Bandhu College, Dr. Mukhopadhyay served as an associate professor of physics at Sundarban Mahavidyalaya for over 15 years. His research focus lies in theoretical and computational physics, with a particular interest in condensed matter physics. Dr. Mukherjee is a dedicated professional with strong expertise in data analysis and practical experience in working with tools like Python and applications. With a passion for teaching and a keen interest in solving real-world problems, Dr. Mukherjee has consistently contributed to building innovative and impactful solutions. He has been involved in organizing and coordinating institutional programs and was a co-editor for the book Relevance and Impact of Free and Open Source Software in the Era of Globalization. So without further delay, I would like to invite Dr. Mukherjee to keep the virtual stage, obviously. So before we begin, I kindly request everyone to keep their microphones muted during the session to avoid any background noise or interruption. Please cooperate. Thank you.
Thank you, Pramita. I think I am audible but not visible, right?
Yes.
Okay. Let me present. Let me present my screen first.
You can make yourself visible too.
No, not necessary. Okay. Uh, well, good evening, everyone. First, I'd like to thank our principal, Dr. Subrata Kumar Ray, for allowing us to commence this workshop. I am Dr. Kisor Mukhopadhyay, the convener of this workshop. We welcome all to the data camp solving real world problems using AI and Python. You must have noticed in the last 12 months, generative AI has moved from a novelty to a necessity, reshaping industries from healthcare to finance. But how do we, as practitioners, move from simply using these tools to building them? Our goal in this workshop is to bridge the gap between theoretical knowledge and actionable practical applications using Python, focusing on solving actual tangible problems. Whether it's developing predictive models to enhance decision making or leveraging large language models to increase efficiency, AI is no longer optional. It is fundamental. This is not just a lecture series, it is a hands on experience. We have crafted sessions to be highly interactive. So I encourage you to ask questions, engage with the tools, and dive into the data. We will focus on number one, practical Python for data science and machine learning. Number two, solving real world business or social challenges using artificial intelligence. And number three, building a hands on interactive learning environment. This is what I conveyed you as a convener. Now let's turn to the topic. The topic is decoding tomorrow, how data science and ML are redefining our world. Let us briefly discuss the history of the data science. The foundation era, before 1960, that was the era of statistics. The focus was purely on mathematics, probability theory, and manual data collection. Early pioneers like John Grant he was working with mortality tables for his demographic analysis. He is the pioneer in that field. Modern foundations were later laid by Ronald Fisher, who introduced hypothesis testing in early 90s. So the DNA of the data science is rooted in traditional statistics. Now the digital transition, the rise of computers, the inventions of computers after 1960. So the era which I am talking about is from 1960 to 1980. There, the focus was transmitting from paper to electronic data processing and storage. Computer has been invented, so we do not need paperwork. So people were trying to transmit their paperwork to electronic data storage. John Taki called for data analysis to be recognized as a separate scientific discipline in 1962. In 1970, development of relational database and SQL by Egercord allowed structured data analysis, structured data querying. A relational database is a structured data storage system that organizes information into tables with rows and columns, establishing logical connections or relationships between them. It uses structured query language, that is known as SQL to manage data and ensure high data integrity and accuracy through predefined constraints and ACID compliance. In 1974, Peter Nor proposed data science as a synonym for computer science. So this era solved the problem of how to store and organize the data at scale. Nothing else. Just transition from paperwork to the electronic data storage and organize the data. So this is the development between 1960 to 1980. Okay, so let's proceed. The important era, 1990 to 2010. The focus was not only the paperwork, not only storing the data inside a hard disk, rather extracting hidden patterns from massive datasets. The massive dataset is known as big data. It is commonly known as big data. So the focus has turned into extracting hidden patterns. Just uh, see the previous slide again, once again, the previous slide. What happened? Uh, just the previous slide. Okay, where uh, the goal was to store the data in a digital media. But in this era, ideas have been developed to extract hidden patterns from the raw data. In 1997, Zeph Yu suggested that statistics be renamed as data science. In 2001, William Cleveland published a formal action plan to establish data science as a distinct field. In 2005, the release of APAC Hadoop enabled the processing of vast unstructured datasets. What is that? APAC Hadoop is an open source framework managed by the APAC Software Foundation that allows for the distributed storage and processing of massive datasets across clusters of community computers. It enables high throughput, fault tolerant data processing using simple programming models, making it ideal for big data analytics. In 2012, Harvard Business Review famously named data science the sexiest job of the 21st century. So, the focus has been shifted from what happened, that is only reporting, to what will happen, that is prediction. So, I think you understand what is going on. So, I again repeat, the focus has been shifted from what happened. Previously, it was only task to report what happened. From a dataset, you extract what happened. But now the task is what will happen. That is the prediction. Isn't it exciting? Yes, it is exciting. Now the modern era. The modern era introduced artificial intelligence and autonomous analytics. That is from 2015 to the present era. What is the focus? The focus is integrating deep learning, cloud computing, and automated decision making. I can't believe it. The key milestone is the deep learning breakthrough. That is the revolutionized image and speech recognition. So today's focus is on generative AI, real-time insights, and data ethics. Data science is now an autonomous engine driving every industry from healthcare to finance. Now, where is the data? How can we get the data? The answer is data is everywhere. But where? This is the source of data. How much data you want? You have PDF file, that is data. You have video files, that is data. You have image files, that is data. You have audio files, that is data. You have Excel sheets, data. You have Facebook, you have Instagram, you have Twitter, everywhere. All these are in the form of data. You must be astonished. Why I am calling these are data. But believe me or not, all these are data. But there is definite way. There is a way out to find out how to extract the data. I will talk about that. There are two types of data. One is the structured data. Okay. That is the database tables. Another is unstructured data. That is image, text, video, or audio data. Just look at this picture. In the left hand side, you see the structured data. That is, you have a database table. You have a database table. So this is structured. You have Excel sheet. This is a structured data set. You don't need to extract. It is extracted already. But there are some data source which is called unstructured data. That means image, text, video, audio data. All these are unstructured data. You must be surprised that why this is called, why an image is data. Believe it or not, an image as data is a digital structured grid of numbers, which is known as pixels, right? You must have heard that there are several pixels in an image. What is that? Where each value of the pixel represents color intensity, right? How do computer interpret this? Computer interpret images not as visuals, but as a 2D matrix, that is array of numerical values, usually ranging from 0 to 255. The number is important, 0 to 255. An image is the array of numbers. The number lies between 0 and 255, where 0 is black or no color and 255 is white or full intensity. Okay? Now what about the audio file? To explain an audio file as data, you can describe it as a digital representation of a sound wave converted into a series of numbers that a computer can store and process. Then you ask, what about the document? Is it a series of numbers? No, I don't believe. No, you must believe that document as data treats unstructured or semi-structured information like PDFs, emails, or reports as actionable datasets rather than just static text. Then what about the video? A video file is a structured digital container such as MP4, AVI, or MOV format, right? That wraps together multiple data streams. Primarily, video is nothing but sequence of image frames and audio alongside metadata. Metadata means subtitles, timestamp, resolution, etc. So into a single file that has been compressed into a single file. Not compressed, that has been included in a single file. This data is heavily compressed by codecs like H.264, which only store image changes between frames to reduce file size. Anyway, so all these are data. So the question was, where is the data? The answer is data is everywhere. Okay? So now let us discuss the data as image. As I previously mentioned you that the data can be transferred into different set of data. Sorry, the image can be transferred into data. So how do you feed data to machines? Suppose you have scan reports. Suppose you are a doctor and you have scan reports of different patients. This can be transferred into two-dimensional data. This is the observation. This is the forget about anything. Suppose this is the scan report. The prediction is no disease. This scan report tells the prediction is 1. That means it has disease. This scan report tells there is no disease. This scan report tells there is a disease, there is a disease, there is a disease. Okay? Now, this image can be converted into numbers. There is so many ways to convert this image into numbers. So, given this set of numbers, given the different types of set, you can predict in which type will tell you the disease is there or not. Let me explain more. Now, data as document, the same thing. Suppose some customer has gone to the market to buy MG Pro speaker, and he or she is observing some reviews. Some review says speaker volume is very bad. The decision is negative. Some review says good price and condition. The decision is positive. That means the good review. What a phone! A very nice phone. MG is the best. This is positive. Stunning pictures, but not so good. Negative. Amazing camera and battery. Good idea. Positive. So the document says the review based on this review, the decision is Y, and if you transfer this review into numbers, so for a set of numbers you get the output. Okay, so for first set 1.9, 3.2, minus 9.8, minus 6.7, 1.2, the result is negative. For another set, the result is positive. This is just observation. I don't do anything. This is just observation. We have a document. We transfer the document into numbers and we transfer the decision. This is just to train ourselves that for this set of data, the result is negative. For another set of data, the result is positive. Nothing else. We have to do nothing. So data can also be transferred. Document can also be transferred in the form of data. Now, how do you feed the data to machines? As I mentioned, as I discussed, that the spreadsheet can be expressed as set of data, notebook, image file, video file, audio file, everything can be transferred into data set. Now, let's go ahead. Then what is data science? So we understand the data. We understand where to get data. Now we have to understand what is data science. This is an interdisciplinary field as mentioned by the principal of our college. It is an interdisciplinary field that uses specific methods, algorithms, artificial intelligence, and machine learning to extract actionable insights and knowledge from structured and unstructured data. We don't know about artificial intelligence right now. We don't know about algorithms right now. We don't know about machine learning, but the data science will deal with this, these scientific methods, algorithms, artificial intelligence, and machine learning to extract some actionable insights and knowledge from two types of data, either structured and unstructured data. So we understand which are structured data, which are unstructured data. Now let's proceed. So what is the definition of this data science? The study of data to find patterns. This is the basic thing. Not our idea is not to report extracting the raw data, not to report extracting the raw data, but to study the data to find patterns. That means we have to find whether there are any hidden patterns inside the data, inside the raw data. So the goal is transforming this raw data into actionable insights to improve business outcomes, maybe business outcomes, maybe educational interest, maybe for solving complex problems. So find the pattern from the data and extract the pattern to improve business outcomes or solving complex problems. So what we need, we need the data, we need to learn data science, we need computer science, mathematics, statistics, and business strategy. The technique involves data mining, data analysis, predictive modeling, and machine learning. So, data science is a mix of all computer science, mathematics, statistics, and the domain knowledge. If you don't have domain knowledge, you can't do anything. If you don't have idea about computer science, you can't do. If you don't have mathematical knowledge or statistics knowledge, you can't do. So you have to have expertise in these fields: mathematics and statistics, computer science, and the domain knowledge. So don't worry, I will explain it more lucidly because I myself understand very less. Now, the question is, how does a doctor analyze the data? I'm not a doctor, but I am trying to understand how does a doctor analyze the data. Suppose the patient is lying there and the doctor is observing the patient. So how do humans make decisions? How a doctor make decisions? He makes decisions from his or her past experiences, nothing else. Past experiences. Whether the patient, suppose a patient has been admitted for dengue, the doctor is supposed to identify whether he or she is suffering from dengue or not. So what symptoms can predict the patient is suffering from dengue? The doctor will observe that whether the patient has rash, whether the patient has fever, whether the patient has headache, whether the patient has cold cough, whether the patient has vomiting tendency. If all this, if all of this uh, observed from this patient, definitely the patient is suffering from dengue. But suppose a patient is having rash only, no fever, no headache, no cold cough, no vomiting. The doctor will say no. The doctor will say no, you don't have dengue. You are not suffering from dengue. But if the patient suffering from rash, if the patient having rash, fever, headache, and vomiting, but not having cold cough, experience says it must be a dengue. It must be a dengue. Then the doctor, clinically, the doctor will say the patient is suffering from dengue, right? So out of five symptoms, out of five symptoms, if the patient, if the patient was suffering from four symptoms, it must have dengue. But if not, the doctor will declare that the patient is not suffering dengue. This is the decision making by a human. This is the decision making by the doctor because he has past experiences. He has past experiences. Let's proceed. Now, can we make this a table for this observation? Yes, because we need data to analyze. If the patient having rash, it is one. If it is, I mean, if it is yes, then one. If it is no, then zero. This is the policy. So, if the patient having rash, it is one. If the fever, if there is no fever, zero. If the headache, if the person doesn't have headache, it is zero, and so on. So, a table has been formed for different type of symptoms, and the answer is on the right hand side. So if the data feature is like that, 10000, the output is 0. If the data feature is like 10010, the output is 0. If the data feature is like 11101, then the output is 1. And again, if the data feature is 10110, then the output is 0. So we have transformed all these inputs into number and output also. The number is only 0 and 1. The number is only 0 and 1. So the table is full of 0 and 1. This is the decision making from our past experiences. So, yeah, very interesting. Very interesting case. In a cricket match, how the umpire decide that the batsman is out or not. The batsman is out or not. The decisive factors are whether the ball is pitching in line, whether there is any impact with the bat, whether the height is over the wicket or on the wicket, no ball or not, whether the shot was attempted or not. So make the table. Again, make the table. Depending on this, the umpire will decide whether it is out or not. LBW, I mean, in the case of LBW, in the case of LBW. So if the data pattern is 11010, then it is benefit of doubt. No. If the data pattern is 11100, then it is out. The LBW is correct. If it is 11101, again it is out. And again 10110 represents not out. Understand? So this technique is also applicable in multiple domains. This technique is also applicable in multiple domains. You can imagine any domain, and you can try for that. So this is the human experience. This is the experience which helped us to make a decision. So what is the semantics of decision making? These are the features: skin rash, fever, headache, cold cough, vomiting. These are the inputs. The doctor will think about fever. It has fever, rash, cold. No, no cold cough. Okay. Vomiting, slight. Headache? Yes. Oh, then it must have dengue. Okay. So these are the features. Features means skin rash, fever, headache, cold cough, vomiting. These are all these features, and the doctor makes a rule. And the doctor makes a rule. If this happens, then the patient is suffering from dengue. If some of them are present, then no, the patient is not suffering from dengue. Okay, so the doctor himself or herself making a rule, to decide whether the patient is suffering from a particular disease or not. This is the clinical technique, because he knows or she knows from his experience that if these symptoms are present, then this disease is present. If these are not present, then this disease is present. Okay. So it is the rule making system. This is the rule making system. This helped him to decide whether the output will be 0 or 1. So Can we take help of some expert systems? Better replace the doctor. We don't need a doctor. We have all the features and we know the results. So let us establish an expert system and tell him, if this criteria is present, then the output will be this. Suppose if high fever and cold cough present, then return no dengue. Or if high fever, vomiting and no rash, then there is no dengue. Otherwise, if high fever, vomiting and rash present, then say it's dengue. This is sort of coding. So I established an expert system and I fed the data into the system and gave the input and gave the output. So if the unknown data comes, its job is to find whether it is true or false. So let us understand what exactly the expert system and why do we need the expert systems. We need expert systems because there is no emotion. There is no emotion because a doctor has some emotion, but if you replace the doctor by an expert system, so there will be no emotion. The second is the high efficiency. The doctor can get tired, but the expert system is not. Expertise in a domain, it is equipped with all the material. So the system is expertised in a domain. Number 4, there is no memory limitation. A doctor can forget anything, but the expert system cannot. Now, if you regular update and improve the and regular update the system, you can improve the performance. A doctor cannot update regularly. Very few doctors update themselves. I'm sorry to say. Sixth, the high security. The high security. Okay. And 7, consider all facts. The doctor can miss some fact, but the expert system is not. So, expert system is a branch of artificial intelligence computer program designed to emulate the decision-making ability of a human expert in a specific domain, such as medicine, finance, or engineering. Now, there are some limitations. Suppose you have a task of hiring someone for a job. What are the factors? He should be 10th pass, he should be 12th pass, he should be graduate, he should have some CGPA greater than some value, he has done some projects, he has some publications, etc., etc. He has got some awards. So feed the computer, feed it into the expert system. Feed it into the expert system. You want, if she or he got greater than 90% in 10th class, greater than 90% in 12th class, and graduate, that person will be hired. Second case, greater than 80% in 10th class, greater than 80% in 12th class, and CGPA greater than 7, he or she should be hired. And the condition is, if she or he get less than 70% in 10th class, less than 70% in 12th class, he or she will not be hired. This is the condition we have fed into the expert system. Okay. So what is the limitations? So this data, I mean, there are several applicants in this table. There are several applicants, 10th marks, 12th marks, graduate, CGPA, projects, etc., awards, etc., etc. This is the tabular form, and these are the inputs, and we fed it into the expert system. Okay. So expert system have to evaluate this data and decide whether the person will be hired or not. What is the problem? The rules can be sometimes inexpressible. Okay, if a man was present there, he or she might think otherwise. That person was honest, and I saw honesty in his eyes. But the expert system cannot. The expert system has no emotion. This expert system cannot identify this, that person is honest or that person is dishonest. So how do you judge honesty? By giving some features? It is impossible. It is just impossible. Even only a man can do it, but not an expert system. And sometimes the rules are unknown. Suppose in case of Ebola, how do you predict the person having Ebola? You don't have features. You don't have no high fever, headache. You don't have features like sore throat. You don't have features like weakness. You don't have features like nausea. Some Ebola, task of predicting Ebola becomes very, very difficult when rules are unknown. So for unknown data, suppose you are matched with dengue, or you are matched with other diseases but not equipped with Ebola. So how can you predict Ebola? You can't. So this is the problem of expert systems. Okay. So right at this moment, we have 4 challenges that typically any large scale rule based system actually faces. First is lots of data. In this era, we are dealing with big data. In this era, we are dealing with big data. An expert system may fail in dealing with this big data. A lot of rules which are hard to write down. All rules cannot be written. All rules cannot be written down. That is very difficult. How many rules? How many rules you will write there? Is it possible? No, it's not possible. Third, and sometimes the rules themselves are inexpressible. Like whether the person is honest or not. These rules are inexpressible. We can't even write them as a Boolean condition. The rules being unknown. Some rules are there which is unknown. So, to overcome these limitations, we look at machine learning. So, this is the introduction of machine learning. And I wanted to explain why do we need machine learning. Artificial intelligence, I will not talk about artificial intelligence. Machine learning is a part of artificial intelligence. If the artificial intelligence is the big circle, then machine learning is part of artificial intelligence. And this smallest circle, deep learning is also a part of machine learning. So deep learning is a part of machine learning, and machine learning is a part of artificial intelligence. So these are not the separate entity. These are all correlated. Now, first of all, let us understand what is algorithm. Algorithm is nothing but a finite set of well-defined step-by-step instructions or rules designed to solve a specific problem and perform calculation or accomplish a task. Okay? So if you want to build if you want to make some building, you need some plan. You hand over the plan to the architect and tell him it's your plan. Then he will do accordingly. So algorithm is like that. It is a set of instructions that has been fed into the system, and system will follow the instructions. This is called algorithm, nothing else. Now, traditional programming, what we do, we input the program in the system and get the data. Okay. Suppose calculate the area of a circle. We feed the data. We feed the input. What input we need? The area of a circle is pi r square. So we give the value of pi as input. We give the value of r and tell them and tell it to calculate pi r square. So we input the program in the system and get the data. But machine learning is different. Why different? The art of making the system to learn from the bunch of data and come up with the best approximate relationship between the input and output. Here, what we do, we feed the data and the system gets programmed automatically. We don't need to making a code. You just feed the data. The system will get programmed automatically. Okay. So the difference between traditional programming and machine learning is in traditional programming, we input the program in the system and get the data, but here we feed the data and the system gets programmed automatically. We will discuss it more detail. Okay. So this is this traditional programming and this is the machine learning. So what we have to do through a structured life cycle, that transform raw chaotic information into actionable knowledge. We have to go through a structured life cycle which will transform the raw data, chaotic information into actionable knowledge. This is the process. So first what we do, we collect the raw data. You see, lots of noises are there, but we need to know which kind of data we actually use. So this is the filtering. Scientists are filtering the raw data into valuable data to extract actionable knowledge. So the collection of sources, maybe your Facebook page, maybe Kaggle website, maybe sensors, maybe some logs. Okay, you have to clean these data. First, you collect the data, filter the data you actually need, and from needed data, you have to process and clean. The second step is you need the data to process and clean the data by filtering, scrubbing errors, and organizing. Okay. The third step is, if the data is filtered, if the data is clean, then you have to explore the data. What data you get, you have to explore the data and analyze. And you have to build the hypothesis from this data. So, making hypothesis, making visualizing the data, applying the statistics, and making hypothesis formulation, you have to make the model and predict. So you have gathered the knowledge about the data, you have visualized the data, you have extracted the insights of the data, you have applied the statistics, you have formed hypothesis. Then your task is to build knowledge using algorithms, machine learning, and training. So you have built the model. So such model, you feed the data, all the data, you feed all these data inside this and train this model as far as possible and get the result and make predictions. Okay. Finally, you have to interpret and communicate. So decision making has been done, and you have to interpret what you have got. You build the report. That is the actionable insights, and check whether the report is correct, how much correct it is, how much accurate it is. If it is not accurate, then recycle it. Then let the model learn that your prediction is not correct. Your prediction is not correct. You rectify and reinterpret and again communicate. Okay. Now, let us go to the real example. That is traditional programming versus machine learning technique. Traditional programming is just a recipe you write, a set of instructions. The chef is reading the set of instructions from the book. He is assigned to make an omelette. Okay. He is assigned to make an omelette. He is reading how to. He doesn't know anything. He is a new but efficient. He doesn't know how to make an omelette. So the purpose is you give the computer data and rule. That means you tell the chef that how how to prepare the omelette. The recipe is like heat pan to 180 degrees centigrade, add 2 eggs, stir for 3 minutes. What is the problem? The problem is if the eggs are larger than usual or the pan is thinner, the recipe might fail. Right? Now here ML is a chef who looks at thousands of these dishes. This is the traditional programmer. I mean, this is the traditional programming technique. This is the machine learning machine learning technique. You place thousand finished dishes and figures out the recipe themselves. There are different types of omelets. Some are burnt, some are not so burnt, some are perfect, some are not so perfect. Different types. The task of the chef is to learn which is perfect, which omelette is perfect. So here, instead of giving data and rules, which traditional programmer wants, here we give data and answers, right? If you provide data and answers, this will give you the rules. Okay. Now the chef, you show the 100 machine, you show the you show the machine 100 photos of perfect omelets and sorry 1000 photos of perfect omelets and 1000 photos of burnt ruined eggs. The chef notices patterns you might have missed. In algorithm, some patterns have been missed, but the chef notices patterns you have missed. The chef says, wait, every time the pan is in this specific shade of red, the egg burns. I should probably stop at this shade. In a particular shade of red, I should stop. That means the chef automatically learns when the omelette is perfect. But here in the traditional programming, you didn't have that instruction, so it will fail. Okay. Now, what is the life cycle? First, you have to set your goal. Second, the data collection. Third, cleaning. Fourth, exploratory data analysis. Five, you have to model the system. And six, the deployment. So this is the machine learning workflow. So first is the problem definition, then the data processing and cleaning, then evaluation deployment, then training and tuning, then feature engineering, then exploratory data analysis, then collection, again the problem definition. So this is the life cycle. Now, let us go to the goal setting. I have an omelette shop and The customers are standing on queue. The question is, are we trying to make the tastiest omelette, the cheapest omelette, or the fastest omelette? The impact. The goal is fastest. If the goal is fastest, the temperature of the pan becomes a signal. The temperature, the temperature of the pan, it's a signal. If the goal is cheapest, the brand of the pan becomes noise. Here I use two terms. One is signal, another is noise. The signal is very important. We need the signal. We restrict ourselves to signal. If the goal is fastest, the temperature of the pan is the most important thing to consider. So it's a signal. If the goal is cheapest, then which brand of the pan you are using, this is immaterial. This is basically noise, right? Now, gathering experiences. So what kind of data collection we need? We need input data, right? In the omelets of example, input data is the pan temperature, weight of onion, type of oil, and time of the day. In data science term, it is known as features or variables. Okay? Now the outcome. The outcome might be customer loved it. Oh, that's fantastic. The outcome might be customer sent it back. Oh, so sad. Or it was burned. In the data science term, it is levels, target. Now, the question of volume. Recording these details for 1,000 different orders. This is in the data science term called the data set size. So the data collection is like taking a snapshot of the entire world around your business. Before the machine can learn, you must first give it a high quality photo album of experiences to look at. Now the data cleaning. From messy real world data to useful information, right? Yes, the left hand side. The left hand side is your kitchen. The left hand side is your kitchen. You won't believe. You just go to your kitchen, it will look like that. But the right side, the right side is the cleaned kitchen. So what we have done, the signal and the noise. What is the signal? I told you. The signal is the meaningful pattern that leads to a successful outcome. The noise is all the random, irrelevant information that comes with the data. The metaphor is that data as organized experience. Your data like as a messy, unorganized room filled with everything. The messy room, 1,000 omelets, some burnt, some raw, some perfect, along with notes on the weather, the chef's mood, and the price of gas. This is the messy room. Which are important? The sorting process is you put the important things into a bucket and you put the unimportant thing into another bucket and discard it. So the portion you need, you put it in the signal. The portion you do not need, put it in the discarded box, right? So machine learning is like a professional organizer who enters that room. They begin sorting items into two types of boxes. Box A, the signal, items that actually matters. What matters? What items does matter? Pan temperature, cooking time, egg quality, that does matter. But items that doesn't matter, items to be thrown away. What song was on the radio? This is not related to cooking an omelette. The color of the floor doesn't matter. It is the noise. You have to discard these features. Okay. Now preparing the ingredients. This is very important step of machine learning. Preparing the ingredients. Missing values. So for the omelets of example, someone ordered, but the collector forgot to write down what they ordered. What we have to do? This is really problem. What we have to do? You have to fill it with the most popular dish or delete the record. What in Excel, in real example, in the Excel sheet of say 1 lakh data table, somewhere there is a missing value. There is either there is blank or something. So you have to fill with some average values or some mean values or some standard deviation added values or something. You have to manage that or delete this column or row which has no record. This is the practical problem. Another problem arises duplication. Suppose two rows are same, duplicate. In our workshop entries, we observe that two rows are same. The same person registered twice. So what we have to do? We have to delete one, right? We have to delete one row. I mean, the same customer was recorded twice by mistake. So remove the extra entry. So the set isn't biased. Another problem is outliers. A record says someone ordered 1,000 omelets. It is impractical. Someone cannot order 1,000 omelets. It is outliers or errors. So correct it to one or remove it as mistake. Right? Right. Just a minute. Just a minute. Now, the fourth point is the inconsistency. One record says cheese omelette and another says CHZOMLT. These are same. Somebody recorded as cheese omelette and somebody recorded as CHZOMLT. Those are same, but you have to standardize, make the levels uniform, make the levels uniform. So the computer understands they are same, right? Now the part is exploratory data analysis. Okay, EDA is the detective work. Before the machine starts learning, the human must start understanding. We look for the shape of the data so we know which path to take. In this stage, we ask the data simple but powerful, common sense questions. The average. At what time? Do most people arrive? Most come at 9 a.m. The spreads. Is there a huge difference between the cheapest and the most expensive order? The correlation. Do people who order extra chili also order more lassi? The oddities. Wait, why did 50 people order omelets at 3 a.m. last Tuesday? Was there a festival? This is the exploratory data analysis. Now, the modeling phase, connecting the dots. The SEP takes the tablet filled with data and starts looking for connections. What is the action? The SEP notices that every time the person in a suit, that is a data feature, suit is a data feature, comes at 8:30 a.m. They order a cheese omelette. That is the prediction. And the model is the SEP creates a mental rule. If the man comes with suit in the morning, then cheese. This is a simple model, right? Now, training versus testing. This is a crucial concept to explain simply. Training is the SEP looks at the first 800 entries on the tablet to learn the patterns. Testing is different. Testing, the SEP takes the last 200 entries, hides the result column, and tries to guess what those people ordered. If the SEP guesses right, the model is good. So a model is just a simple or complex function that best describes the relationship between our input and output. Okay? Deployment, putting the SEP to work from the notebook to the frying pan. What is deployment? In the previous steps, the SEP was practicing in a quiet kitchen. Deployment is the moment you move that SEP into the real shop. The action, the machine learning model is now live. It is no longer looking at past data. It is looking at a new customer walking through the door right now. Now, the prediction part. The model looks at the customer, say a student arriving at 8 a.m., and whispers to the SEP, based on everything I have learned, there is a 95% chance this person wants a spicy masala omelette. Start cooking it now. Now we have to scale, which is not possible with a single SEP. That is the super SEP. A human SEP can only manage one shop, right? A deployed model can be copied instantly. So model can be copied. A human cannot. A model can be copied instantly. You can now run 1,000 omelette shops across India, all using the same intelligence you built in your one test kitchen. So you have only one test kitchen and you deployed the model, copied instantly to run 1,000 omelette shops across the India, all using the same intelligence. Now monitoring. This is very crucial. Is the omelette still good? Learning, not compete. The drift concept. What is the drift concept? What if tests change? What if tests change? What if a new health trend starts and people stop wanting cheese? the feedback loop will work. You must keep watching. If customers start sending the pre-cooked omelets back, we need to take this step back to the training phase. So learning is not complete. Once you deployed the model, once you deployed the model, your task is not complete. The model task is not, your task is not complete. You have to go through the drip concept. You have to adopt the concept. If the people's taste changes, you have to change yourself. You have to change your model also using feedback loop. Now, machine learning is classified into three categories. I'm running short. One is supervised, another is unsupervised, and another is reinforced. Let us discuss briefly because time is very short. I have to complete. So this is the supervised learning, level data. This is the type of machine learning where an algorithm learns from examples, like a student learns from a teacher. The model is trained on a level dataset. This is apple, this is dog, this is cat. This is so the model is being trained. Here, the child is the model, and you are the teacher. You are teaching him. Yeah, this is apple, this is dog, this is cat, and so on. Okay. So, which means every piece of input data is paired with the correct output or answer. That's why it is called supervised learning. Now, this is unsupervised learning. So, there is unleveled data, a type of machine learning where algorithms learn from unleveled data without human supervision or predefined correct answers. Right? You have to learn from this. You have to learn. You have to learn from your experience. Okay? So this is the type of machine learning where algorithms learn from unleveled data without human supervision or predefined correct answers. This is known as unsupervised learning. Now, the type of learning I'm showing is the reinforced learning. This is a type of machine learning where an algorithm learns to make decisions through trial and error, similar to training a pet or teaching a child. Basically, খেটে খাও ভাই. There is no teacher, there is no level data. You learn from your experience. You learn this. So learning continues. So the simple example of supervised learning is detecting spam or not spam. How it works? It gathers level data, train the model, and make predictions. You show you teach the model that these data are these emails are spam, loan application, hana tana, etc. etc. These are spam. You mark them as spam. So you are teaching the model that these emails are spam. We do not need, but some models we need to read. Sorry. Some emails are we need to read. You mark it. So You have classified which are spam, which are not spam. So you gather the level data, train the model, and make predictions. Now, unsupervised learning, to find the pattern, how this works, gather unlabeled data, train the model, make predictions, evaluate, and refine. Repeat this process again and again because you don't have labeled data. Here you have unlabeled data. You have to train the model that this is the apple, this is the spam, this is not spam, etc., etc., and make predictions. It may fail, but from this failure, it, it will learn that which is correct or which is not. And then reinforced learning. Just how you teach your pet. She, you give it award. Yes, doggy, if you do it, I will give you a piece of mutton. If you fail, I will not. This is the learning process. This is known as reinforced learning. So, by experience, it will feel which is correct and which is not. The next, the concept. I will take just 5 or 6 minutes to complete. Okay. The concept. AI/ML is not a crystal ball that predicts the perfect future. It's a mirror that reflects our past data. What is the problem? If our past omelets of data shows that we only served men in suits, the model might learn a biased rule. Only people in suits like omelets. This may not be correct. The dirty part is that if the data we collect is dusty or biased, the mirror reflects a distorted reality. The machine isn't being evil, it's just being too obedient to bad data. What is the solution? This is why we can't just set it and forget it. The role human must act as the ethics and the police. We must check the omelets of results to ensure we aren't accidentally discriminating based on noise like gender, age, or clothing. Right? Now, this is the present day. Sorry. This is the present day. This is the day of deep learning, where our brain cells are going inside a computer. Not exactly. In the left hand side of this picture, this is the structure of a neuron, and this is the nucleus, and I think this is called axons, like that. Okay. So these neurons are connected to other neurons with these branches. In the same way, we can build a model which is called the node, and several neurons can be attached with each other, just like actual neurons. Several nodes can be attached with each other, This is called deep learning network. This is the input layer. These are called the hidden layers, and this is the output layer. So give input to the input layers and find the output at the output layer. This is the present day we are doing with this. Just imagine, human cell is being incorporated in the computer. Well, so yeah, it doesn't have a moral compass. It only has the data we give it. If the data is biased, this set will serve an unfair omelette every single time. The human questions what most people really want to know about AI is the first question is the machine actually thinking? The answer is no. Remember our shape metaphor? The machine isn't inspired to cook. It's just very good at following the patterns it saw in thousand previous omelets. It is mathematics, not consciousness. And the second common popular question is, will AI replace my job? The answer is AI is a tool, like a faster stove for a chef. It won't replace the chef, but the chef who uses the new stove will likely outperform the one who refuses to touch it. It replaces tasks, not the people. Data science isn't about making a perfect report. It's about deployment. It's about taking those hidden patterns we found in the maze and using them to make better, faster, and smaller decisions in the real world. An ML algorithm is just a machine's way of saying, I have seen this before, and here is what happened next. Thank you very much. Any questions?
Thank you, sir.
Any questions or
Thank you
comments?
so much. If anyone has any queries, please feel free to ask.
So, hello sir, am I audible?
Yes, very, very noisy. Very noisy.
As well sir, it is better actually now.
I can't hear you properly. It's very noisy. Can you write the question here, or can you? Uh, yes, now it is audible, I think.
Okay sir, my question is actually good sir.
Yes, yes, yes.
Okay. And now we actually use Gemini, ChatGPT like AI models.
Uh-huh.
So under which classification do you think it is? Like supervised, unsupervised, or do you force it? It is not a force.
Oh, I mean,
Actually,
you wanted
these,
to know Chat GPT and this in which category, right?
yeah, is it supervised or unsupervised
Oh, there
actually?
is no. Actually, we can't classify this kind of jobs because there is a mixed concept. There is a mixed concept. It may use supervised learning. It may use unsupervised learning, depending on the situation. Depending on the situation it faces.
Okay,
You
sir.
cannot,
Thank you.
you cannot classify particularly ChatGPT uses only supervised learning or only this. Actually,
Unsupervised.
it uses deep learning also.
Okay, sir. Thank you, sir.
Okay. Any other questions? I think it's very hard to you because without break, uh, but it's online. You have the freedom to get a cup of coffee during the lecture. The speaker has the problem. Any other questions?
Uh, I'm Dr. Mukhopadhyay.
Mhm. Yes, please.
Can you hear me?
Yes, I can hear you.
One of the slides, uh, at the very beginning, I suppose, I
Mhm.
don't remember exactly. You
Mhm.
said that uh, one needs to have much knowledge about for to take in to know about this uh, data
In
science and all this.
okay.
Uh,
Let me show.
I think you said that uh,
This
one has
before.
to have, yes, exactly, computer science, data science,
Yes,
maths and statistics, and I think this is what uh,
domain knowledge.
domain knowledge.
Mm.
So as a geographer, I
Mm.
have a simple question.
Sure.
Can't geographers take entry to this science?
Absolutely, because geographer needs data science because you are dealing with data, right?
Exactly. Yes, exactly.
You,
Statistics and all,
yeah,
and not
yeah,
only statistics, we have to have a huge source of data.
yes. Actually, you desperately need data science. As a geographer, you desperately need data science
No, but
because
the geographers might not have this the knowledge about computer science, math,
don't
computer science
you don't need,
domains.
you don't need about you don't need much about computer science. We are not doing any vast things of computers. You are not making the computer architecture. So the basic knowledge of computer science is sufficient. The basic knowledge of mathematics is sufficient. I mean linear algebra. The basic
Okay,
knowledge of statistics, different kind of distributions,
okay.
basic knowledge,
Because
domain knowledge.
some of our students from
Mm.
geography department, they are also participating, I think. So
Yes.
for them, they might think that it's not their domain. That's
No,
why
no, no, no,
I
no.
asked the question. And
Absolutely. It is the domain of geography because
yes,
geography vastly uses data.
data. Yes. Okay. Thank you.
Welcome, sir.
Thank you for your lucid elaborations.
Any other questions? I think there is no other questions. Dr. Howley, shall we
Yes.
stop? Shall we stop right here?
So, yes. So, thank you once again, Dr. Mukhopadhyay, for that insightful and engaging session. As we come to the end of the session, I would like to thank each one of you for your active participation, and we will reunite tomorrow at the same time at 7 p.m. Okay,
Thank
thank
you.
you
Thank you.
and good night.
Thank you. Good night.